Hi, this is Aaron with iBoard Repair, and today I'll be recovering data from an iPhone 12 Pro Max that's been damaged by ocean water. So very severe water damage data recovery in this case. I haven't done anything to this phone yet, so let's take a look at the board. So I've done nothing to this phone yet. All I've done is open up the screen. I haven't even disconnected it yet. And as you can see, we have a lot of corrosion throughout this phone. And I'm not too sure how severe the actual motherboard is, but I do see a lot of corrosion underneath this shield. So my very first step is going to be to take this motherboard out of the housing and examine it more closely. So I'll do that. So there's going to be a lot of issues on this device, I'm assuming. There are some spots that don't look too bad, but I'm nearly certain there's going to be a lot of damage within the sandwich of this device, so the layers. I'm seeing a lot of corrosion around my power button connector here, or around the components that lead to it, I should say, and that could be a problem. So I think the first thing I'll do is measure these lines to make sure that neither the power button nor the volume buttons are shorted to ground, because that will cause the phone to go into different modes. So I'll turn on my multimeter here. And with one probe on ground, I'll measure these pins. That one is supposed to be ground. That one is the power button line. And some of these other ones are the volume. I think that's already going to be good. Double check to make sure that that's supposed to be ground. And yeah, it looks like that line is supposed to be ground. So my power button and volume buttons are good. Check that off the list. I also think it's going to be worth it to remove this shield here, so I'll just use some wire cutters to do that. There's an IC in this corner I have to be careful about, so I don't crack it when I pull open this shield. And yeah, that definitely needed to come up. I have a lot of corrosion right here. This is an IC that controls touch, and it looks like it may be damaged. I believe this is an, I thought this was an audio IC, but I'm not sure what this is. Let's take a look at it. So what is this IC right here? We can get an idea by looking at the lines. Display. So this is the display IC. Oh, I just very recently changed this IC on a different device. I remember this pattern with the L ground, the ground, and the two OLs here. So yeah, this will control image. So image lines, or at least the image IC, is most likely going to need to be replaced. Possibly the touch IC as well, which is over here. We can see 1v2 touch goes through it. And with that much corrosion in this area, I think it's also going to be worth it to split this board. So I'll do that next. I should also check to make sure my NAND lines aren't short, so I think I'll do that first. So I'll take my multimeter probes again, and I'm not quite sure where the lines are, but I'm just looking for 3 different values. I know there's 3 power rails here. So 0.35 on one line. This one looks like it's probably going to be short because the inside is usually the line. So ground and short. So we do have a short there. That's probably the same line. 0.35, that's the same as this first line. 0.35. 0.4. So this is one line, 0.36. This is another line, 0.4, and this is a line that's short. So let's
Let's check out what that is.
So this was the 0.35. My 2V625 NAND line was good. My OV83 NAND line was good, so this should be 1V2. And 1V2 doesn't necessarily have to be NAND. I believe it goes to a few other locations. Not that many. And one thing with 1V2 is that it goes to my EEPROM chip. And I'm always concerned when I see this line short that it may have scrambled the EEPROM data. So usually that doesn't happen, but it is something I think about. Let's see if any of these little capacitors in that water damaged area might be the culprit. Otherwise, I think I may try to inject into here and see if we see it anywhere. But I'll probably do that after I split the board. No, I guess I don't need to. Yeah, so I'll check to see if possibly this capacitor is short just because it's in that water damaged area, and then I'll probably inject into that line to see if anything else heats up if that's not it. So I'll do that before I split the board. Also, now is a good time to check to see if my main line is short. And I can check that probably at these two capacitors here. So I'll take my multimeter probes again. And these were the two caps on main. And yeah, main is short. So far, I'm seeing these two chips that need to be replaced, one for image, one for touch. I'm seeing a NAND line that's short, and I'm seeing my main line short. So there's definitely a lot of things going on with this board, and I'm glad they came to me. If this had gone to somebody a little bit less experienced, they probably wouldn't have much luck with this device. There's a lot going on with it. It did go to like a U-break iFix first, but they're not really motherboard technicians. They're, they change screens. So I'd say there's a decent chance that the 1V2 line is short right there. That was actually the capacitor. I'll just brush this with some isopropyl alcohol right now. So now that this capacitor is gone, let's check to see if the 1V2 line is still short. And no, that line actually cleared, so it was just that little capacitor right there that was causing the 1V2 line to go down. Now that that's removed, that line should be fine. And I think I'm going to remove this shield as well because I do see some corrosion down here. There's probably not damage inside here, but just in case, I think I want to check. And it looks fine under there. I have a lot of charging components underneath this shield. Might as well take it up too while we're at it. And it also looks pretty good under there. And I'm pretty sure I'm seeing corrosion around the interposer down here. So I'll just go ahead and split these layers now with my heating platform. So this is the heating platform I like to use. And I have a 12 part on here now. Platform on here. You can switch those out to whatever one you needed, like this is an 11 Pro. So I'll turn this on. Mine's set to 235, but it doesn't really get that high. It gets to about 226, 227, and then it starts to go down from there. And I just, I'm not quite sure why it does that. I just think it can't quite get as high as it's set to. At that point, I'll usually use a little bit of hot air to finish it off if it doesn't want to come up. But we'll wait for this to heat up. And once it does, we'll pull these apart. Okay, this is at 226 now. Should be about ready to pull up. So I'll add a little bit of top heat. I like to use a hook tool to pick it up. And there we go. So I do see a bit of damage on this bottom board. Not too much, but even a little bit's always a problem. And if we look at the other side of the top board, we got a little corrosion here. I got to check if this is main. If so, that's probably short. But besides that, this other half is looking pretty good. The 12 Pro Max specifically is the only model within the 12 series that needs the bottom board connected in order to prevent the temperature sensor from going off and not allowing you access to the data. So I'll have to use a known good bottom board in order to prevent that. There is a method actually that you can use to like add a resistor and not use the bottom board, but in this case it looks like the pads are fine. It's going to be easier just to connect it to a known good bottom board. And I just took a quick look at the board view, and it does look like this is on main, both of these. So I'll remove these to make sure it's not contributing to my shorted main line. The small one almost surely is shorted. Big one probably too. And it also looks like this cap is on the main line as well. I might as well just take it off. It's not needed to have on the board, and it may be short. I'll have to make sure to check out this area pretty well and make sure that the board itself is not short to ground. It's pretty damaged here. Let's measure with the multimeter and check to see if main is still shorted. I'm pretty sure it will be. Oh wow. So that's interesting. 0.53 is not a normal main reading. So this part of main may be isolated from the rest of main at this point. Yeah, if I measure on the actual via here, I'm still getting a short. But this part is not measuring short. But if we go back to this cap, I'm almost sure it's going to measure short still. And yeah, it is. So what that means is these were on main, but the pad is no longer directly connected to main, which is at that little tiny dot right there, that via. So if I measure on the pad itself, no short, but not a normal main reading, it's too high. On the via, yes, short. That's actually the rest of main. So most likely it will just be these two chips that are still giving me a problem. I'll have to make sure the surrounding components are still good. Some of them may be needed to have touch and image function properly. And I see a lot of components around the image is damaged. So I'll go ahead and just remove both of these chips now and get them ready to be replaced. And I see my CPU is directly on the other side, so I'll have to have very precise control of my heat. Otherwise I will overheat the CPU and cause much bigger problems. So that's something you need to consider if you're ever removing components in this area. You have to know what's on your other side and not overheat it. I think I'll remove this one first. So I'll add some flux. And the biggest thing is I just have to make sure my aim is really good. So the chip itself is heating up faster than anything else, and it will allow me to pull it right away. I normally like to work on a paper towel like this, but in this case I don't really want to have pressure on the CPU while I'm heating right above it, so I'll put this onto a platform. And there we go. Now I shouldn't have pressure on the CPU while I'm heating this area. Let's add a bit more flux. So that definitely had issues underneath it. I'll pull the touch chip now as well, because this one is less likely to have issues, but I still strongly suspect it does. But if it doesn't, I won't be terribly surprised. And this one also looked like it had issues. So now's a good time to see if my main line is cleared or not. And I still have some damaged capacitors, so it may not have. I know it has. So we can see on my multimeter up there, 0.29, 0.3, that's normal. It should be closer to 0.34 or 0.32, but the board's a little hot, so that's changing the reading a bit. So at this point, the board is most likely okay. I think I will remove this capacitor, maybe both of these, just because they look pretty bad. And the line doesn't measure short anymore, but you know, maybe they're not fully connected. And with a little bit of pressure, it might bring the line back down. So now, even with these two chips off, this board should boot up. So I'm going to clean this up a little bit more, and then I'm going to test the boot sequence on my DC power supply to see if it looks like it's booting or not. And the only thing I'll do before that is I'll check to make sure the CPU looks okay and that no solder balls are popping out or anything like that. And CPU is looking just fine, so that's good heat control there. I'll just clean up this side of the board before I test the boot sequence. But at this point, I expect that the board is most likely booting. I do have some like 1V8 and 1V2 lines around this area, so I'll have to make sure those aren't short. I am very glad to see that the components around my PMIC look very clean. When it comes down to it, this water damage wasn't as severe as I expected it to be, and I'm very glad to see how good this side of the board looks. I'm just going to check out this area right here. I know that the components under here are 1V8 and 1V2. I want to make sure they're not damaged. They're not short, I should say. That's what I'm actually checking for. So that was these ones right here, and there's 1V8 S2 and 1V2 S2. Those are CPU lines. 1V8 S2 I believe is RAM. Yes. So I'll just make sure those are okay. Measure the inside points right here. One of them 0.27, the other one 0.24. That looks just fine to me. So I think I'm safe to check my boot sequence now. So I'll turn on my DC power supply. I believe red goes to the outside on this model. Let's see. Yes. So I'll short the power button line, and we want to look at this reading up here. It looks good so far. If it jumps up to like 0.2 and then keeps moving, then I know we're good. That looks good enough to me. I don't need to keep holding it. So that does look like the board is booting, but at this point it has no image and no touch. Once these chips are back onto this board, then we should have a working device, enough so that we can pull data from it. The only pads I'm really worried about, or the only other things I'm worried about, are whatever this is, this, and maybe some of these. I should check out what those are and see if they're going to be needed for these chips to function or not. So when there's a single capacitor like this that goes to a chip and goes to PMIC and doesn't do anything else, almost always that capacitor will be needed. This one's on main, and there's a lot of other capacitors around that are doing its job, so this one isn't needed. This one isn't needed, this one isn't needed. So it's okay, all of these ones. So it's okay if all of these are gone. I'm not worried about those. And I'm pretty sure these were gone. These resistors are for sure going to be needed in order for display to work. It's my I2C display SCL. And this is the SDA line. So those are both absolutely going to be needed. In fact, even more so than needing them for display. Actually, this one doesn't go to display. But these are just needed to boot. When they go from 1v8 to the CPU and they're missing, I'm almost sure that this phone would be stuck in like a 0.06, 0.07 brain dead mode. So a lot of people will ask what to do when they see a brain dead device, so stuck low amperage. These resistors would be one of the reasons why it would be stuck low. If they were missing or damaged or something like that, these are not something that people will typically check. So this resistor is actually needed for display. This one's probably not needed for boot, but it's needed for display, it looks like. But these two, they're needed for boot because they go to the CPU. If they're missing, like I said, this phone's going to be stuck brain dead. It's a little deceptive because it says I2C display, so you might think it's just needed for display, but no, this is going to CPU. I'm almost certain these would be needed for a boot up as well. I suppose it is possible they're just needed for display, but usually if it's 1v8 on one side and goes to the CPU on the other side, even if it goes to the image chip, it's needed to boot up the phone. For example, I know for a fact on the iPhone 6, actually 6S, if I'm missing these resistors, the phone will be stuck in brain dead mode. And I've seen that many times in my years of data recovery, and it's very similar. So it goes to 1v8 on one side, and on the other side it goes to the image chip, which is chestnut right here, and also to the CPU. And if this one is missing, the phone will not boot up. So I assume it's the same for the 12 Pro Max I'm working on. Could be wrong. I haven't tested it itself, but I assume. These were the only other components I needed to be worried about a little bit. These two caps are probably okay if they're missing because I have other bigger caps over here. This resistor, on the other hand, is almost surely going to be needed. I have to make sure that's good. And then this resistor is also going to be needed. And those I2C resistors, they look fine. This resistor is not looking so hot. This was on main. This is the one that goes to, I think, this pad, and that's probably fine. I'm going to remove this cap that's on main because it looks really bad. These don't look great, but they go to these other caps over here. Let's measure them and see if they're short or not. This one is actually on main as well. I'm going to remove it. It looks really bad. I'm not getting a reading on that second one, so I'll just measure at these big caps that the line is on. And I'm not getting any reading, and that's because the chip is missing, and that also confirms that those are not short, but I'll remove them either way because they just don't look very good. This resistor looks pretty bad, but just as an experiment, I think I'll leave it as it is. And if I don't have image, then I know that's most likely going to be an issue. And even the one underneath it doesn't look great either, but that one looks more likely to be okay. This one might be okay as well, but I don't know. From this angle, it doesn't look as bad. It might be fine, actually. This one, and this one are all on my 1v2 sock line. And I'm pretty sure they're not going to be short, otherwise I wouldn't have had a good boot sequence, but they don't look very good. And yeah, they're not short. I believe that's the normal resistance on that line, but I think I'm going to remove those anyway. I don't like them. They look really bad. And there's plenty of other capacitors on this line that can... Oh wow, that's almost... usually when it breaks like that, that would mean it's short. So I'm curious if it measures short now. Still no. But it is measuring much higher, much more different. So maybe those lines were partial short and the PMIC was just able to power through that. And I can kind of confirm what that reading is supposed to be. So this is the line I was just looking at, 1v2 sock. And this is a CPU line. And if it was fully short and it couldn't supply the voltage, I would be getting an amperage spike on my DC power supply when I prompted this phone to boot. But usually the reading under the PMIC or the reading under the CPU is what the reading should be. Whatever one is lower is the one that it should be when they're both on there. So here 0.33 is what I'm seeing. I think I saw 0.32 and this is 0.48. So again, when both of these chips are on there, it's whatever one is lower that you'll most likely see on the line. So when these capacitors were on the line right now, I was only seeing 0.09 or 0.10. Now that I've taken them off, it's at 0.33. So this line was actually partially short right now. It's just that the PMIC was still able to provide enough voltage to power through that partial short, and the CPU accepted that it was good enough. But I'm glad I took those off. You know, that could have been stressing the PMIC and could have been stressing the CPU. And, you know, it's possible the phone would have died during the recovery or something like that if I had left those on. So that's a little bit of a tricky one, something you should pay attention to. So again, if I measure this now, 0.34. So that's much more normal of a reading on that line. So at this point, I'll just go ahead and rework these pads and get new chips on here. And I actually have a lot of, or not a lot, but I have a couple different temperatures I use on my iron for different purposes. And I had it on the wrong temperature, which is why I left some solder on this board when I didn't quite mean to. If I look at my board view, that little bridge I have right here, it's both ground, so I'm not even going to worry about clearing it. Those pads are looking much, much better now, and these should be ready to accept a new chip. So I'll just clean up these other pads now while I'm at it. My normal soldering iron temperature is 350, which is a little bit lower than what some people will use. And if I want to put solder down, like onto if I'm creating a jumper or I just want solder on like one point, I'll move the iron down to 300. And that allows solder to stick to whatever I'm touching a lot better. When I'm trying to clear solder off, I'll keep it at 350. And I like to supplement with some hot air like this on top, and that allows me to reflow these pads nice and shiny, as you see over there. Those pads were in a bit worse of a condition, but they should be good enough to take the chip. I don't know if you noticed, but I had bridged these two and I just cleared that with my tool. That's something you'll want to keep an eye out for when you're reworking on your own boards. If you see bridges, those lines do not go together. So looking okay. And I'll go ahead, these aren't chips that I stock, so I'll pull them from a donor board that I have here. Here's a donor that I have. And the chips look really good. I don't really... It's probably safer to reball these chips after I pull them, because I can put low melt solder, or at least leaded solder onto them. So I don't have to worry about overheating the CPU when I place them. But I do have leaded solder on these pads. So for the sake of saving a little bit of time, I'm going to try to do a clean pull of this one. So just lift it without disturbing the solder balls, and then put it back onto the board without doing a reball. I'll remove this little capacitor first, because that's kind of the spot that I want to grab with my tweezers. And this board, you know, it's just a donor. I don't care about it. I'll go ahead and put the data board onto the platform first. And I do have to be a little bit careful. I noticed that this capacitor became loose, and that's because these are a little bit too deep. So I was kind of hitting the capacitor with the side of this board. So there we go, that's good. I'll remove this chip now. And when I'm removing donor chips that I don't want to reball, I tend to overheat the board a little bit. It just makes it easier to pull it up and know that all the balls are liquefied. And again, you're only, of course, going to want to do that on a donor board. This has a nice ground around it, so when that melts, I know that this is for sure melted. Nice reference, I should say. Well, I saw that it was moving, so I just went ahead and pulled it up. And yeah, that looks like a pretty good pull. You can see the solder balls underneath are undamaged. So I should just be able to place this back onto the board. That should already have enough surface tension to not blow away. It is a little bit crooked, but it will twitch into place once it's ready. There we go, I saw a little twitch. And I don't want to go too long because again I know the CPU is right on the opposite side. So I'll do the same thing for this other chip here. This one will be a little bit harder. I think I have enough room. There we go. Another clean pull. I couldn't really see that one twitch into place, but I was a little bit nervous I was supplying too much heat. But if we look at the CPU, no solder balls around the PMIC, and that's what we want. Let's see if I can get a view of the solder balls underneath the chip. I may have to give it a little nudge to make sure everything's connected. But honestly, I think it's going to be good enough. So now it's time to see if this board is booting. So I'll grab my parts, my jig, and put it together, and let's see if it's booting. I will clean it first. That's the last step I'll take. I guess one thing that may be important to note, not really for data recovery, but for repair, is the fact that I'm getting a different reading on this pad here from way earlier than I am on main. And what that would indicate to me is that there's some chips right around this area that are connected to this pad, otherwise I wouldn't get a reading from it, but it's still not connected to main. So again, this doesn't matter for data recovery, but for repair, whatever chips are connected to these pads are not going to be receiving the voltage that they need to operate. I'm not really sure what these chips do. They're probably for service or Wi-Fi or LTE or something. But I am pretty sure they won't be working until I reconnect them just to that little via right there. Just need to make a little solder ball from the pad to the via, and these would reconnect again. So just a little note that I thought of. And I guess if you weren't here for earlier when I was looking at this spot, I'll show you real quick. If I measure on this pad, which is VDD main, I'm getting 0.53. If I measure on the via right next to it, I'm getting 0.3. So these lines are no longer connected. But this wouldn't be 0.53 unless it was connected to some other chip. And that also means that whatever chip is connected to is not connected to main. So I just wanted to clarify that if you missed what I was talking about earlier, or you missed when I removed these components. Okay, I got my known good parts here, so I'll connect them. And I guess I won't put it in the jig right now. I don't have a computer free to take the data yet, so I'll just see if this is booting. And I will have a temperature sensor warning right after it boots because it's not connected to the bottom board. And I expect it will boot. Yep, there we go. We got an Apple logo. I was a little thrown off because I didn't see an amperage draw, but that's just probably because the battery's full. And actually, no, we're getting an Apple logo boot loop, it looks like. So I do still have something going on here. Yep. I wasn't really expecting that. So I really don't like that. Mainly because I know that my 1v2 line was partially shorted. And I'm always afraid of my EEPROM data getting scrambled here. I do still have corrosion around these chips, but you know, I'm not quite sure what these do, and these almost never give me a problem, even when they're a little corroded. So if I'm getting Apple logo, that's most of the way through the boot sequence. That means it would go to recovery mode if I told it to. Okay. So it's kind of nice that most of the damage was isolated to this one area, because I can see that this resistor here is almost surely not connected anymore. I'm almost curious to see what I would get if I tried to do an update to this, because it should go past recovery mode. But right here I see signs that this resistor is not connected. You can see it just came right off. And that resistor looks like it's important. Let me show you what it is. So this is the resistor. PPOV7 VDD low S2. This is some CPU line. And on the other side of the resistor, it also goes to the CPU. PPOV7 VDD low UL PPLL. And I don't know what this does, but it's some sort of communication line for the CPU. And it looks like it's important. Sorry, that's the wrong line. PPOV7 VDD low FL PPL. Yeah, is that what I said earlier? UL PPL. Yeah, so the one I was looking at was the UL PPLL. This is the FL PPLL. So I don't know what that is, but again, that's still, it's some CPU communication line. And that is almost surely going to be what my problem is here. And this is just some obscure resistor, and that's why it's very, very, very important to visually check your components that are damaged, because this isn't something that would be part of my normal radar. The only thing I would normally ever really check this for is for voltage right here. And that voltage is almost surely going to be there because it's still connected to the PMIC and the CPU. It's just the other side of this resistor right here is some communication line, and that's not something I would normally check. But because I knew I had a lot of water damage in this area, it's very important to check all your resistors. Resistors are more important than capacitors. Sometimes capacitors can be very important. Like on this one, if this was missing, I probably wouldn't have display, because again, this is the only capacitor that goes to the display IC as well as the PMIC, and there's nothing else. So that's almost surely going to be needed. But resistors are even more important, and if something's wrong with, if one of them looks visually wrong, you need to check out and see what it is, because it might be very important. Not every resistor is important. Some of them are for, I don't know, like for camera or for service or something like that. But this is just CPU. This is just going to PMIC and CPU. So for sure, that resistor is important and it's needed and it's broken. So I kind of want to see what will happen if I do an update to this phone with this missing. But to be honest, this is a customer data job, and you can't really be doing experiments on customer data jobs. You just need to fix what you see is wrong. I don't even like to supply voltage when I know that shorts are on the board still or something's wrong. So I think once I replace this resistor, I think hopefully the phone will boot. So that will be my next step. And that was the only resistor that looks very, very bad to me. Right here. There are many, many techs who would just not have known what to do when they saw that this phone was not booting. And again, that's why, like I said, if you see any resistor that looks damaged, you need to check out and see what it does, because a lot of them are very important. This is also one of the main reasons, if you just message me for help and say you have a repeating Apple logo, there's almost zero chance I can tell you what's going on with that device, because this is not part of the normal diagnosis right here. This is not something somebody would normally check, because it's something that would almost never go wrong. And the tip I was using was not quite sharp enough to get into this area, so I switched it up. So I'm having a lot of trouble getting solder onto that pad, but let's see if I'm getting a reading from it yet or not. I'm getting a ground reading, and that should not be ground as far as I know. But it does look like the pad right next to it right here is ground, so that's probably actually what I'm touching. This is a very small area. If I zoom out, you can see it's very hard to get anything into there. Try one more time. There we go. So 0.25. So I do get a reading there. Let's see if I can add just a bit more solder. And if I can, then I'll go ahead and place my resistor from my donor board. So this is a good time for me to lower my temperature on my soldering iron. I moved it down to 300, and it allows solder to grab to the board a little bit more easy at that temperature. So I'm not getting much onto there. That's probably good enough. Yeah, it looks like there's plenty of solder on there on that pad. It's just that most of that pad is missing, I believe. Should be enough for a resistor to take hold. So here's my donor board again. And it's probably smart to take a measurement on that resistor and make sure it's supposed to be 0.25. And it is. I see 0.25 on my multimeter. 0.26 on the other side. So I'll just I'll take this component, move it over. Here we go. Okay. I think we should be good to go. I'll just have to make sure I have a measurement on this side, and that's giving me the 0.25. And add 0.26 on the other side, and if those are good, that should be connected. And hopefully this phone will now boot. Yeah, it looks good enough. I do believe we're connected. I hope. So let's try these parts again. So let's see what we got now. Still got an Apple logo. And hopefully it will boot up this time. There we go. Temperature sensor is what I wanted to see. There we go. So this is fully booting. It's just giving me the temperature sensor warning because it's not connected to the bottom board. But this is going to be successful. I'm going to go ahead and take this apart now because, like I said, I don't have a computer available to plug this into currently at this moment. But that was very interesting to see. So I did run into a last minute surprise there. I was missing one single resistor, the OV7 line that was connected to the CPU. And that was causing the phone to repeat on the Apple logo. So Apple logo boot loop. And again, a lot of people will message me and they'll say they have a symptom like an Apple logo boot loop. And this kind of demonstrates why it's almost impossible for me to pinpoint what the problem is or to give somebody advice like that, because this is a resistor that I have never seen go bad before. It only went bad because water damage was localized in this area. But this would be like one of several dozen or even hundreds of reasons why you would see a repeating Apple logo. So saying you have a repeating Apple logo is not enough information for someone to give you a solution. I wasn't expecting that was going to be a problem, but it's kind of cool to see, and it kind of shows the curveballs you can get when you're working with data recovery and why it's really important to go to a data recovery expert that's going to be able to check every single option when it comes to looking at these boards. So it was a cool job. I'm glad I decided to make a video on this one. Basically what I saw was a 1v2 short on NAND as a very first step. That cleared when I removed a capacitor. Then I saw my VCC main line was short, and those two chips were bad as well. So the touch IC and the display IC, as well as some general cleaning and some other issues. So thanks for watching this video. I hope you learned something, and I hope you enjoyed it, and I hope you stop by again. You have a good one. Bye-bye.